Hi, everybody. This is Mr. Youngren again, and we are actually almost done with everything that we're going to do with quadratics, just two more lessons. And what we're going to do in this lesson today is we're going to work on going back and forth between our two different forms of a quadratic. So whether that be the standard form or the vertex form, we're going to try to figure out, can we go from one form to the other, okay, and vice versa. Before we do that, I'm going to actually have you graph these two functions. So reviewing some of the things we covered earlier in this unit. So as always, go ahead and hit pause, work through this opener. All you're doing is working on graphing it, and then we'll go from there. So hit pause and then go ahead and unpause once you're ready to look at what you should have for the opening problems. All right, here is your work for the opening problems. And one thing that we should notice right off the bat, that the graph is the exact same, right? We have a vertex at 2, 3 and an a value of 1. And so we're going to get the exact same points for both graphs, and thus for the exact same graph, even though their equations look different. And so that's, like I said before you worked on this opening problem, that's what we're working on today. So how can we go from this form to that form without having to use graphs? Can we do that algebraically? Hey, and also vice versa. So what do you notice about two graphs? They are the exact same. We can write the same quadratic graph in multiple ways. All right, so we're going to do just two different things. We're first going to go from vertex form in the standard form. Now, before we jump into that, here are the steps we're going to follow. So this is a good thing to refer back to. So the first thing, it's really following order of operations. That's still going to apply when we're trying to distribute everything out or multiply everything out and get it in the standard form. So if we think about order of operations, the first thing that we have parentheses, but we can't simplify the parentheses. And so there's nothing left to do there. So the next thing to do is to deal with the exponent. So step one is saying use your area model to expand whatever's in the parentheses squared. Now, I always encourage students to think about what this means. When we square something, that really means we're multiplying it by itself. So I want all students to actually write that down, because when I see it as x plus 3 times x plus 3, I know exactly where to go to. I'm going to use that box, right? That factor box or the area model to help me multiply. When I see it like x plus 3 squared, it's tempting to want to just say x squared and then plus 3 squared, but we're actually missing a whole bunch of terms. That we don't want to do that. So we're going to go ahead and make our box. We're going to multiply x plus 3, x plus 3. I get x squared, 3x, 3x, and 9. So x plus 3 squared is equal to x squared plus, if I combine my like terms of 3x and 3x, plus 6x plus 9. And so what I'm going to do is I'm going to leave this in parentheses, and I'm going to replace it with where the x plus 3 squared was in my equation. Now, there's a reason why we're leaving it in parentheses, and that's to catch if we actually need to distribute or multiply some value inside there. So it depends on what our a is. So since a is 1, we're really distributing a 1 to the inside of these parentheses, which doesn't change anything. So the parentheses actually don't matter here, so I'm just going to get rid of them. And the last thing to do is to combine any like terms, and that's just going to be the 9 and the negative 6. So x squared plus 6x plus 3. And there's our equivalent form that's now in standard form, right? So we really didn't do step 2 because the a value was just 1, but we do want to make sure that we're paying attention for that. And we're going to actually do that in number 2. And then the combining like terms, that was me adding 9 and negative 6. So let's go ahead and do one more. And again, we're going to start with order of operations. So parentheses, nothing to simplify. Exponent, yep, we have x minus 4 squared, which means we're multiplying x minus 4 times x minus 4. I'm going to use a box for that. So as we start to multiply, I get x squared, a negative 4x, another negative 4x, a 16. And then bring it all together, I have x squared. Combine my like terms, negative 4 minus 4 is negative 8x, and plus 16. And just like we did last time, I'm going to bring this quadratic, which is equivalent to x minus 4 squared, and put it in parentheses where the x minus 4 squared used to be. Everything else needs to stay the same. So I still have this negative, then I have x squared minus 8x plus 16, and then plus 5 at the end. So this is the case where our a value is not 1. Rather, if it's just a negative, it's -1. And so we do need to distribute this a value into all these terms. And that's what step 2 is saying. Multiply by the a value. Now, it's only going to what's in the parentheses and not that 5 there at the end. Right? If we were to read this out loud, it's -1 times x minus 4 squared. So we're doing that -1 times what x minus 4 squared is equal to, which is x squared minus 8x plus 16. So the 5 is just going to stay the same. After we distribute, I get -x squared plus 8x minus 16, and then plus 5. And so then combining the like terms, -16 plus 5 is -11. And now we have our equivalent form in standard form from what it was in vertex form. All right, we're gonna now actually flip the page over. There are a couple that you can do on your own. I'm gonna actually save these for you to work on in class, and we're gonna jump down to now doing the opposite. And if we have an equation in standard form, can we get it into vertex form? And we've kind of actually done most of these steps here before when we graphed quadratics in standard form. So essentially what we need to do is find the vertex. If we can find the vertex, we can easily put it back into that vertex form. And then the only other thing we need is the a value. And the a value, as long as our quadratic's in standard form, is the number in front of the x squared or the number right after the equal sign. Right, so let's go ahead and do 1, and then I'm gonna actually pause and let you do number 2. So looking at number 1, and again, we have steps. It says identify the a value. I'm gonna go ahead and do that just real quick. So a equals 1, and we're gonna need that later. So the next thing, it says find the x squared of the vertex using the formula x equals -b over 2a. We're gonna start with that right now. So -8 over 2 times 1, or -8 divided by 2, which is -4. And so now what we're going to do with that x value is we're going to sub it back in to the equation to find y. When you do that, make sure you're putting the -4 in parentheses, especially if you're plugging it into your calculator. It just helps keep the order of operations going smoothly. And so I'm not going to use a calculator. I can deal with these numbers because I know that -4 squared, or -4 times -4, is a positive 16. 8 times -4 is -32, plus 12. Once we get down to just subtraction and addition, we're going to work left to right. So 16 minus 32 is -16. And then after we add 12, we get -4 as well. So the vertex is at -4, -4. And these are the only two things we need to now write an equation that is in vertex form. So I'm just going to look at that equation and plug things in where they need to go. So a is 1, h is -4, but really because it's minus h, it's plus 4. We know that because we're always switching the sign on the x coordinate when it's in parentheses. And then the y coordinate, or k, is just -4. So our equation is y equals 1. I don't need to write that 1 there. I like to do it just so I clearly see that I put in the right a value. And then x plus 4 squared and minus 4. Right, let's have you all try number 2. So just like you did with the opener, you can hit pause and then you can check back in after you've worked it out to see what you should have. All right, here's your work for number 2. I started off by just identifying the a value again and writing it down so I know where to use it when I go ahead and write my equation. So it's -1. Then doing -b over 2a, -b means switch the sign on what b used to be. So now it's -6 divided by 2 times -1, which gives us an x value of 3. And when we sub that back in, we actually end with the y value of 0. And so the vertex is at 3, 0. And there's a couple ways we can write this. If I use all the numbers based on what we have them written down and we don't leave out any of those imaginary or the numbers the invisible numbers, excuse me, it would look like y equals -1 times x minus 3 squared plus 0. But like most of you already know, I don't need to write plus 0 because adding 0 doesn't do anything. I also don't need to write the -1. Rather, it can just be a negative. And so If you cleaned it up, you could also write it as y equals negative times x minus 3 squared. These are the exact same thing. And there's not a preference for you writing one equation over the other, whatever works best for you. All right, the rest of the work you complete in class. Thanks for watching. And as always, make sure you complete your video check-in and have a great rest of your day.